Hi everyone, I am Cataldo Musto from University of Bari, and in this presentation, together with Ellen Stark from University of Bergen, we will try to introduce our work about a knowledge-aware food recommender system exploiting holistic user models. So basically, in this presentation, I will talk about food recommender system. The goal of this technology is very intuitive because they basically aim to identify the most suitable recipe for a target user, given some characteristics of the user or some constraints. Currently, the literature in the area of food recommender system has three main issues. First, content-based approaches are not effective because they are typically based on similarity between ingredients. So content-based food recommendations tend to suffer of over-specialization. Similarly, collaborative approaches are not effective because they suffer of popularity bias, and as some work has shown, popular recipes in food domain are typically unhealthy. So through collaborative approaches, we are not able to recommend healthy recipes, and this is not good. The third problem we have seen is that most of the approaches have a limited understanding and also exploitation, of course, of very important features about the user, such as BMI, mood, or how much physical activity she has done. And this is, in our opinion, an important limitation. Accordingly, in this work, we try to tackle these issues, and in particular, we propose the exploitation of knowledge-based recommender systems to avoid the problems of both content-based and collaborative approaches, and we propose the use of holistic user models to build a richer and more comprehensive representation that allows to encode and, again, exploit such under-investigated features of the users. This is our methodology. Here you can see the workflow we carried out. The first model is the profiler model, whose goal is basically to build a representation of the user. In particular, we decided to rely on the principles of holistic user models to build a richer and more comprehensive representation of the user. In particular, we have defined 5 different groups of user features, such as demographics, affective data, behavioral data, health data, and domain knowledge. And here you can see a list of the features that we have encoded in our user profiles. Next, we have the filter component, whose goal is very intuitive because we basically carry out a very preliminary filtering of the available recipes. So, for example, we remove recipes containing meat for vegetarian users and so on. At the end of this step, we produce a set of candidate recipes, so recipes that are suitable for the user. And through the ranker model, we try to identify the most suitable one for her. In order to produce this ranking, what the ranker model basically does is to implement a scoring formula. Our intuition is to exploit what we do know about the user in order to identify the most suitable recipe for her. This intuition has been translated in the formula you can see in this slide. In particular, we calculate for each available recipe a formula that combines a popularity score, so how popular is in general that recipe, with a knowledge-aware part of the formula that basically tries to understand how suitable is that recipe for the user given the characteristics of the user. In order to implement this knowledge-aware part of the whole process, we implemented a knowledge base. The goal of this knowledge base is to encode as rules some common sense and background knowledge about food consumption or about healthy food habits. So, for example, if a user is overweight, do not suggest her recipe with high calories, if a user has done much physical activity, you can suggest her you have to prefer recipes with high proteins and so on. What we do in this step is to activate these rules on the ground of the characteristics of the user. So once our particular rule is activated, we increase or decrease the score of the formula on the ground of the characteristics of the person. At the end of the step, we are able to generate a ranking, and we just suggest the most suitable recipe for the user. Here you have a use case, a very simple use case with a set of available recipes for the user. We first calculate popularity-based scores. Next, we create the holistic user model of the user. In particular, you can see that we have a male user who is overweight. So in the third step, we exploit such information to re-rank all the available recipes by activating some of the rules that we have encoded. In particular, as you can see, given that user is overweight, our knowledge-aware part of the process tend to lower the score of unhealthy recipes and to increase the scores of recipes that can be good for us, such as, for example, a barbecue recipe. So the intuition is that thanks to this process, we are able to provide users with recommendations that are more satisfying for her because they are obtained based on a larger and more comprehensive set of user features. This is what we have tried to do in the experimental part of the process, and I pass the word to Alan to discuss this part of the article.